Hi, this is Alex from devstories.eu. MicroPython, episode 4 of 7. Getting a bare microcontroller onto a Wi-Fi network using traditional C code usually takes hundreds of lines of boilerplate just to initialize the radio and handle the handshake. It is tedious and error-prone. In MicroPython, you can bring up a wireless connection in literally 3 lines. That is the job of the network module, specifically the WLAN class. The network module abstracts the underlying hardware network interfaces. For Wi-Fi operations, you rely on the network.wlan class. A standard Wi-Fi chip can operate in 2 distinct roles. You must explicitly define which role you want when you create the WLAN object. The first role is station mode, specified using the constant sta_if. You use station mode when your hardware needs to connect as a client to an upstream router, just like a smartphone joining a home network. The second role is access point mode, specified using ap_if. In this mode, the microcontroller acts as a router itself, broadcasting its own wireless network so external devices can connect directly to it. Access point mode is incredibly useful when deploying hardware in remote locations where no external network exists, allowing you to connect locally for configuration. Getting your board online requires a specific sequence. You first create the WLAN object using the station mode constant. By default, the physical Wi-Fi radio is powered down to conserve energy. You must turn it on by passing true to the active method on your WLAN object. Once the interface is active, you invoke the connect method with your wireless network name and password. Here is the key insight. The connect method is strictly non-blocking. When you invoke it, MicroPython hands the credentials to the network processor and immediately continues executing your script. It deliberately does not wait for the network authentication to finish. This design allows your main application to update a display or read a sensor while the radio negotiates with the router in the background. However, if your code attempts to send data immediately after calling connect, the operation will crash because the board does not actually have a connection yet. You manage this by polling the interface. The WLAN object provides a method called isConnected, which returns a simple Boolean value. The standard pattern is to write a while loop that evaluates if isConnected is false. Inside this loop, you introduce a short delay, such as sleeping for half a second. The execution pauses here, repeatedly checking the hardware state until the router finally accepts the connection and isConnected returns true. Once the loop terminates, the hardware is officially online. To verify the network details, you call the ifconfig method on your WLAN object. This method outputs a collection of 4 specific items: the assigned IP address, the subnet mask, the gateway, and the primary DNS server. You can extract the first item from this collection and print it to the console to see exactly which IP address the router granted to your board. The non-blocking nature of the connect method means you are always responsible for verifying the hardware state before trying to route data over the network. That's it for today. Thanks for listening. Go build something cool.